You've just crossed the point of no return, the event horizon of a black hole. In 10 seconds, you'll be dead. But you're about to see something impossible, the death of everything. I'm going to show you what Einstein's equations predict happens when you fall into a black hole. And it's way more terrifying than any movie has ever shown. Because you don't just die, you become a witness to eternity. This isn't science fiction. There's a supermassive black hole 26,000 light-years away at the center of our galaxy right now, and millions more lurking in the darkness. The physics of what happens when you fall in. It rewrites everything you thought you knew about time itself. Here's what we're doing. You're approaching a stellar mass black hole, 10 times heavier than our sun, with an event horizon about 30 kilometers across. Your friend stays in orbit far away, watching through a telescope. You're about to experience the same reality, but see it completely differently. Einstein proved gravity isn't a force, it's curved space-time, and time moves slower in stronger gravity. This is real. GPS satellites prove it every day. Their clocks run 38 microseconds faster daily because they experience less gravity. Without correcting for this, GPS would fail in minutes. The event horizon is where escape velocity equals light speed. Cross it, and even light can't escape. It's not a physical barrier. It's a one-way boundary in space-time itself, and you're about to cross it. From your perspective, nothing special happens at the event horizon. No wall, no sensation. You just cross it. You might not even know the exact moment, but looking back up, the entire universe is compressed into a shrinking circle of light behind you, getting smaller and smaller. Now comes the nightmare. Tidal forces. Your feet are closer to the singularity, so they're pulled harder than your head. The difference in gravitational pull between your head and feet is catastrophic. Scientists call this spaghettification. Your body stretches, your bones snap, your atoms themselves are torn apart. From your perspective, you hit the singularity in a fraction of a second, maybe a tenth of a second. That's it, your timeline ends. Everything you are is compressed into a point of infinite density. But your friend watching from orbit, they see something impossible. Your friend sees you slow down as you approach the event horizon. Slower and slower and slower. Your image turns red as light stretches. You appear to freeze at the boundary. From their perspective, you never fall in. You're stuck there forever, your image gradually fading over thousands of years. But you're not really there. You already died. The light carrying that information just takes infinitely long to escape. But here's what makes black holes the most terrifying objects in the universe. As you fall toward the singularity in your final seconds, time outside is moving faster. Not just faster, exponentially faster. Your final heartbeat? Outside, millions of years could be passing, maybe billions, maybe more. In your final seconds, you could theoretically witness our sun expanding into a red giant and dying, stars across the galaxy exhausting their fuel and exploding, galaxies colliding, the universe itself expanding and cooling. Some calculations suggest you could watch the heat death of the universe, the final fade to black as the last stars burn out and everything reaches maximum entropy. The universe's end credits, played at ultra fast forward in your final moment of consciousness. You become the universe's final witness, the last conscious observer, watching everything that ever was fade into nothing, alone. In darkness, in the grip of gravity so strong that not even light can escape. That's what the math predicts. Now, full honesty, for a small black hole like this, you'd be dead from spaghettification long before experiencing this. And the light from outside would be so redshifted you'd mostly see darkness. But supermassive black holes, billions of times heavier, their tidal forces at the horizon are gentle. You could actually survive crossing it and experience some of this time dilation before dying deeper inside. The time dilation? That's not speculation, that's Einstein's general relativity, tested and proven. The math is solid. Black holes really do create these extreme warps in space-time. They're nature's ultimate time machines. Proof that time isn't absolute. It's relative, bendable, and observer-dependent. So here's my question for you. Would you take the fall? Experience 10 seconds of absolute terror to witness eternity? Or stay safe in orbit, watching your friend freeze at the edge forever? Comment your answer below. And if your brain hurts right now, good. That means you're learning real physics. Hit subscribe for more mind-bending space content.